Okay, for today we're going to solve exponential equations, and we're going to solve using a method where they have the same base. So if I have two expressions, b to the x and that equals b to the y, notice how they both have the same number being raised to a power, b. If that's the case, then your focus can just turn to the exponents. Set those equals and solve. So you can forget about the base if they're equal and just focus on solving the exponent. For example, 3 to the 2x power equals 3 cubed. First question you ask myself is, do I have the same base here?
Yes.
Yep, they're both 3. Which means now I can ignore that and just look at the exponents. 2x equals 3. And if I could solve this for x, then I solve the entire equation. So 2x equals 3. Opposite of multiply by 2 is divide by 2. And I get x equals 3 halves.
Amazing.
The benefit of this, or these types of problems, is I could plug in 3 half in for x, and I should get the same value I get for 3 cubed. So you can check your work here with these problems. No excuse not to get 100.
I'm so confused.
Well, let's see one more time. 5 to the 3x equals 5 to the 7x minus 2. Are the bases the same?
Yes. Yes.
They are. So now, just focus on the exponent. Set those equal. So 3x equals 7x minus 2. If I can make these equal, they'll be the same as if these are equal. So let's solve for x here. Let me move x to one side, so let me subtract the 7x here. 4x equals negative 2. Thank you. Negative 4x equals negative 2. And then now divide by negative 4. I get x equals 1 half. There it is. I solved it. So your attention is actually is easier than it looks. Or should I say it's more complicated than it looks. Because we could just look at the exponents. Now, well, what happens if you don't have the same base? So I have this problem. 9 to the 3x equals 3 cubed. Well, I need to set them to the same base. So what number do you think will be the same base that I can manipulate for 3 and 9? I have provided a chart here to help you with that number sense. So these are all the numbers raised to a power all the way up to 10. Which of these values, 1, 2 through 10, do you see that has both 3 and 9?
3 and 3 down there. 3.
Right here, right?
Yeah.
3 is 3 to the 1 power, and 9 is 3 squared.
Oh, I was looking at the one at the bottom, the second bottom. No, go up. It's in the third column. It's in the third column. Go down. Yeah, right there. I was looking at that one.
Why?
Oh, no. We're not looking at powers. We want to look at what the base and the power equal to. So we're looking at this column right here when we're looking for 3 and 9. So thank you. Yeah, I didn't explain that too well. So I know 9 now is 3 squared. So I'm going to change this to 3 squared. And then 3, I'm keeping it as 3. So it's just going to be 3 to the power of 3. So this is 9 to the negative 3x. Now I want you to pay close attention. You have to remember your laws of exponents here.
You gotta multiply.
What do you do to a power that's raised to another power? What operation? Multiplication, yes. So now that I got these at the same base, 3 and 3, I want to just focus on the exponents. Here I need to multiply, because that's my law with exponents. A power raised to a power. So 2 times negative 3x.
Negative.
And that equals negative 3. Yes, negative 6x equals 3. One more step, divide by negative 6. X equals negative 1 half. And I could, if I wanted to, plug that in here for x, just to check my work. What I don't want you to do is what I see all the time with these types of problems. They know 9 is 3 squared, so they turn it into 3 squared minus 3x. They just throw it right up there, like so. That is definitely wrong. That's not how the algebra works. Maybe I could do that. Let's see, smaller size. There we go. Don't do it like that. It is 3 to the 2 power raised to the power of negative 3x. This is how it should be written. Not like this. So let me have you give it a shot while I take attendance. 5 to the 3n minus 2 equals 125.
Oh shoot, I forgot my gold.
So think, what do you set these two that will have the same base? What number?
School.
Okay, let's look at our base.
Oh shit.
I have 5 and 125.
Yes.
Where do you see on the right hand side, right column, 5 and 25?
The 5.
5, right?
Yeah, the second one.
5 and 125. So 125 is 5 cubed. So I'll need to turn that into 5 cubed. So I get 5 cubed here. And this is already at my base of 5, so nothing changed. Now, are they the same base?
Yes.
Yep. So let me just focus on the exponents. 3n minus 2 equals 3, and then solve. Oops, not 3, 2. Should be able to solve a linear equation in your sleep by now.
First, I couldn't do that.
N equals 5/3. N equals 5/3. If I were to plug in 5/3 here for n, this would equal 125. Any questions on this one? So again, our main goal is we want to go here. Same base, same base. Same base. Same base. That way we can just solve exponents. The next one can be kind of tricky. You have to remember your laws of exponents. 2 to the power of 3n minus 1 equals 1. Well, if I have a base of 2, so I'm not going to mess with this one, I have to have a similar base of 2 here, which means 2, I have to find out what power of 2 will make that equal to 1. Nothing, right? What's the math word to say nothing?
0.
0. 2 to the 0 power is 1, just like anything to the 0 power is 1. So if you see 1 and you're trying to change it to the base, the good news is you can change it to any base you want because you just assign it to 0. So think of it as type O blood. You can go anywhere. Alright, so now I have the same base. Let me look at the exponents. 3m minus 1 equals 0 and solve. Add 1. 3m equals 1. Divide by 3. M equals 1/3. Bam, done. M equals 1/3. So, let's increase the difficulty just a little bit for today and look at these last two problems. 3 to the negative 2x plus 1 times 3 to the negative 2x minus 3 equals 3 to the negative x. Do they have the same base?
Yes.
They do. But before I start focusing on the exponents, remember our laws of exponents? What happens if you have the same base and you're multiplying? What do you do with those exponents?
Add them.
You add them. Very good.
Yeah.
So this is going to end up being negative 2x plus 1 plus negative 2x minus 3 minus x. So don't just go ahead and say, okay, the same base, I'm going to jump right into and multiply these exponents because of this sign. Well, when you get into the exponent level, this turns into addition. What if this was division? What would you put here?
Subtraction.
You would put a subtraction sign, yes.
Yeah.
All right, now we're good to go. So let's combine our like terms. Negative 4x minus 2 equals negative x. Let me go ahead and solve for x now. So add 4x both sides here. Negative 2 equals 3x. And then last but not least, divide by 3. X equals negative 2/3.
Amazing.
X equals negative
What did I
2.
just do, bro?
You missed your chance.
All right. So please don't make the common mistake of putting multiplication here just because you see it. Again, when we go to that next level, that turns into a plus. And if that was dividing, that turns into subtraction. Just like with this problem, a power raises to a power, you have to follow that rule of operation, which is multiplication.
That's a lot of work for a lot of guys.
Next, 9 to the negative 2b minus 2 equals 27. I need them to be the same base. So where in this chart do you see 9 and 27?
Over there, down there. the bottom.
3.
On part of that line.
3, right? 3 squared is 9. 3 cubed is 27. So my base is going to be 3.
Oh, I see what you're saying now. So if you was looking for 18 and 64, they'll be at the bottom of 8.
You mean 8 and 64? Yeah, 8 and 64.
It's okay, Jermaine. It takes time.
So I know I'm going to change this to 3 squared. And I need to change this to 3 cubed. That is raised to the power of negative 2b minus 2. Alright, so now that I have the same base, let me look at the exponents. What happens here?
You gotta multiply.
Gotta multiply. So 2 times negative 2b minus 2 equals 3.
Alright, I'm gonna start. I got it slow.
So now let me distribute. Negative 4b minus 4 equals 3.
You can't do it.
Solve for b. Negative 4b equals 7. Divide by negative 4. Divide by negative 4. b equals negative 7/4. Bam! We're done.